So this is a recording which shows you how to balance reactions in an alkalinic environment. It means how to use the OH minus when we have to balance reactions. Those are reactions are actually something that happens not without adding acid to the mixture, but they happen by adding bases, for example, sodium hydroxide to the mixture. So we have a compound you have met before, the permanganate ion, formula MnO4 minus. And if you let it react with something else in an alkalinic environment, it becomes manganate ion. Permanganate ion is purple. The manganate ion is green, blue. So when you see the color change from purple to green, blue, then you can determine that that's what happened. So in this kind of reaction, we'll have the permanganate ion reacting with another compound called the sulfide ion, becoming, in an alkalinic environment, becoming manganate ion and sulfate ion. So the sulfide ion becomes the sulfate ion. The SO3 2 minus becomes the SO4 2 minus. And that's in alkalinic, meaning we add OH minus when it's needed. Alkalinic. All right, so identify the two atoms. Well, look, the magnesium goes from being attached to the oxygen and having only one negative charge to being attached to the oxygen and having two negative charge. So something it has happened. The other one will be the sulfur because it goes from being attached to 3 oxygen atoms to being attached to 4 oxygen atoms. So about the manganese, well, it goes from having which oxidation state? Well, everything must be equal at left side of the arrow to -1. It's here. There are 4 oxygens, they count as -8. And the manganese then must have an oxidation state of +7. So at the left side of the arrow, it goes from having +7 to, and now we look at the right side of the arrow. Well, everything is equal to -2. There are still 8 oxygen atoms, so their contribution will be -8. And still, the manganese will be X. That means, oh, sorry, minus. That means that the manganese, in this case, has an oxidation number of +6. So the manganese goes from +7 to +6. That means it has been reduced, has gained 1 electron. Now the sulfur. Sulfur goes from what? Well, let's have a calculation. The charge of the ion is -2. There are 3 oxygens, so they contribute with a number of -6. The sulfur is our unknown number. Solving this, we get that the sulfur has, in this case, an oxidation state of +4. So the sulfur goes from +4 to 1. Well, on the other side of the arrow, we have got a charge of -2. We have got 4 oxygen atoms. They contribute in all with -8. And we have got our unknown sulfur. That means X is equal to +6. So the sulfur goes from +4 to +6. It has been oxidated, meaning it has lost 2 electrons. So this one here has to be time multiplied by 2, because if the sulfur gives 2 electrons away and each manganese gets 1 electron, then it takes 2 manganese in order to receive the 2 electrons from the sulfur. So that means that we now can balance for electrons by putting a 2 in front of the manganese. Because each manganese gives 1 electron, gets 1 electron, and each sulfur gives 2 electrons away. So it takes 2 manganese to get the 2 electrons from the sulfur. Now we balance the charge. We'll have 2 negative charges due to this and 2 negative charges due to the sulfur-containing compound. Then we have the arrow. And then we'll have 4 negative charges here, 2 times 2 minus, and 2 negative charges here. So in all, we'll have -4 at this side of the arrow and -6 on this side of the arrow. That means that we need 2 hydroxide ions, OH, sorry, minus, in order to balance the charge. So we rewrite our equation and we put 2 hydroxide ion where they are needed. As they are needed at the left, then they have to come here. Then we balance for water. balance with water for H and O. Now you see, let's count the total O, oxygen. We have 2 from this. We have 2 times 4, 8 from this. And we have 3 oxygen here. And at the other side, we have 2 times 4, 8. And we'll have 4 oxygens due to this one here. So in all, we'll have 2 plus 8, 10, 13 here, and 12 here, meaning we need a water molecule at the right side. So we rewrite the whole equation like this, and we add a single water molecule. And then the equation is balanced.